Most companies can build an AI prototype, but almost none can deploy AI that survives real users. The moment traffic hits, everything breaks. The logging, the prompts, the guardrails, the reliability. And if you're in a Microsoft environment, the gap between demo and production affects your workload, your timelines, and your reputation. In this video, you'll learn the engineering disciplines that transform AI prototypes into durable enterprise systems, and how Microsoft teams can use Azure, Semantic Kernel, and ML.NET to close that gap with confidence. Part 1. An explanation of what AI prototypes truly are. A prototype isn't a system. It's a quick demonstration designed to answer one question. Does this idea show promise? Prototypes move fast because they skip every discipline required for real operations. They rarely include structured logging. There is no monitoring. Inputs aren't validated. Prompts are often hard-coded directly in the code. Security is minimal or non-existent. There's no role-based access, no data controls, and no governance. Prototypes assume users behave perfectly. They expect clean text, proper formatting, correct context, and predictable workloads. But in production, users behave unpredictably. Inputs arrive malformed. Traffic spikes at random times. Sensitive data appears where it shouldn't, and cost increases the moment usage ramps. Most teams celebrate when a prototype works once, but a production system must work thousands of times across changing conditions. The truth is simple. Prototypes impress executives because they make AI look easy. Production systems save money because they show what AI actually requires. Without engineering maturity, logging, monitoring, guardrails, compliance, and security, every prototype remains fragile. It will fail the moment real users touch it. Part 2. Why prototypes fail immediately when exposed to real-world data, workloads, and unpredictability. Prototypes fail because they are not designed for reality. In controlled testing, they appear stable, but once real users interact with them, hidden weaknesses surface quickly. The first failure point is variability. AI is probabilistic. It may produce one answer today and a completely different answer tomorrow. Without guardrails, retry logic, or structured prompts, reliability collapses under load. The second failure point is incomplete context. Prototypes rely on perfect examples and curated prompts. Production inputs are messy, ambiguous phrasing, partial details, conflicting instructions, or adversarial attempts. Third, prototypes hide operating costs. A small test might cost pennies. A production workload can produce unexpected API expenses overnight. Monitoring is essential to prevent financial surprises. Fourth, security gaps appear immediately. Hard-coded secrets, open endpoints, and missing access controls create vulnerabilities that prototypes never considered. Finally, prototypes fail because nothing watches them. No monitoring detects drift. No logs show user behavior. No alerts signal degradation. Issues surface only when users complain. These failures aren't rare, they are guaranteed. Unless engineering layers are added, prototypes break the moment they encounter reality. Part 3. Engineering pillars required for enterprise-grade AI. Production AI succeeds when it rests on 5 engineering pillars: reliability, monitoring, logging, security, and governance. Each pillar addresses a predictable failure point prototypes ignore. Reliability stabilizes probabilistic behavior. Structured prompts, deterministic fallbacks, guardrails, and rate limits create consistency. Monitoring gives teams visibility. Prompt drift detection, usage analytics, cost monitoring, latency tracking, and error alerts help teams act before users experience issues. Logging creates traceability. Inputs, outputs, exceptions, and user feedback must be recorded. High-risk outputs require special review workflows. Security protects the organization. Data classification, role-based access, token auditing, secrets management, and anti-prompt injection strategies form the core of safe AI. Governance establishes operational discipline, documentation, model justification, testing policies, update workflows, and bias evaluation. Without governance, AI systems drift into inconsistency. Together, these pillars transform AI from a flashy demo into a trusted enterprise system. Part 4. Reliability Engineering, turning probabilistic AI into predictable enterprise behavior. Reliability is the most misunderstood part of AI engineering. Traditional software is deterministic. AI is not. To achieve reliability, production systems rely on structured prompts, versioned, validated, and constructed programmatically. This reduces variation and increases stability. Guardrails define what responses are allowed or disallowed, preventing drift and protecting users. Fallback logic is another pillar. When the AI produces low-confidence outputs, the system may retry, switch to a deterministic ML.NET model, or escalate to a human. Rate limits and circuit breakers prevent overload. In Azure, availability zones support failover when infrastructure is under stress. Testing completes the reliability picture. Systems must be tested with malformed inputs, concurrency spikes, performance degradation, and unexpected scenarios. Reliability engineering converts AI from experimental to operational. Without it, AI is a liability. With it, AI becomes dependable. Part 5. Monitoring, Logging, and Governance, the operational backbone of production AI. Monitoring, logging, and governance create the visibility and accountability necessary for enterprise AI. Monitoring provides situational awareness. Drift detection reveals when the model's behavior shifts. Usage analytics show how teams rely on the system. Cost dashboards protect against unexpected expenses. Latency and error monitoring ensure performance remains stable. Logging captures every important detail: inputs, outputs, exceptions, and user feedback. High-risk outputs require review. Logs allow problems to be diagnosed in minutes instead of days. Governance establishes discipline. Documentation of model choices, prompting strategies, evaluation criteria, and update policies ensures consistency. Compliance requirements are easier to satisfy when governance is embedded directly into the workflow. AI systems evolve constantly. New data changes behavior. Model upgrades introduce drift. Without governance, updates become risky. Combined, monitoring, logging, and governance form the backbone of enterprise AI, enabling scale, safety, and continuous improvement. Part 6. Security and Risk Management for AI in Microsoft Ecosystems. Security is where most AI prototypes fail instantly. AI introduces new attack surfaces and new data exposure risks. Production systems must be engineered with security at the center. Data classification ensures sensitive or regulated content is handled correctly before reaching a model. Automated redaction may be required. Role-based access control protects who can execute prompts, update them, or view logs. Least privilege access reduces risk. Secret management prevents exposure. Keys cannot be embedded in code. They must live in Azure Key Vault, be rotated regularly, and be scoped tightly. AI systems are also vulnerable to prompt injection. Sanitization layers, guardrails, and system prompts with strict boundaries protect against unintended behavior. Auditability is essential. Every action must be traceable. Every update must have justification. Finally, enterprise AI requires isolation. Sensitive workloads should use private networks, not public endpoints. Azure OpenAI with private access provides this protection. Security is not an add-on, it is a design discipline. Part 7. A prototype to production pipeline for Microsoft environments. Microsoft environments already contain everything needed to take AI from prototype to production. The key is using those tools with engineering discipline. The journey begins with a small prototype built using Azure OpenAI, Semantic Kernel, or a lightweight API wrapper. The goal is feasibility, not perfection. Next, add structured logging through Azure Application Insights. Capture inputs, outputs, timing, and exceptions. Then introduce monitoring using Azure Monitor and Log Analytics. Watch for drift, cost patterns, performance degradation, and usage trends. Monitoring turns AI from a black box into a measurable system. Add guardrails through Azure API Management. Enforce rate limits, validate inputs, block unsafe requests. Insert human review workflows when needed. Now harden security, move secrets into Key Vault, enforce role-based access, add audit trails, and use private endpoints for sensitive workloads. Introduce deterministic components using ML.NET for tasks requiring predictable behavior, such as scoring, ranking, or risk evaluation. Pair generative AI with deterministic logic for maximum reliability. Finally, deploy through controlled environments. Validate in staging. Promote only when guardrails, security, monitoring, and governance are fully satisfied. This pipeline transforms AI from a fragile demo into a durable enterprise system. AI prototypes are easy, but production AI requires engineering, security, and discipline. When you follow a structured pipeline, your team can deploy systems that are reliable, auditable, and safe. If you want deeper insights into real-world AI engineering, explore more of my work. Thanks for watching.